Welcome to Cherry Hill Tuition, where incredible results are achieved. In this mathematics tutorial, I will cover some of the excellent processes used by Cherry Hill to achieve the highest grades. Let's get started. Okay, so there are a few rules that are important to know when working with indices. The square root of a number can be written as the number that you are square rooting to the power of a half. The cube root of a number can be written as the number that you are cube rooting to the power of a third. So hopefully you can see that there is a pattern here. In a more general way, this is what you need to know. Okay? Three over x can be written as 3x to the power minus 1. So currently the 3 over x, the x has a power to the power of 1. So bringing it to the top, all we need to do is flip the sign in the power. Okay, so another example would be 4 over x minus 2. This can be written as 4x to the power of 2. So we change the sign in the power into a plus from a minus. Okay. A multiplied by a cubed is the same thing as a to the power of 1 plus 3, which is a to the power of 4. Okay, so when we're multiplying numbers that have the same base number, for example, a, we can add the powers in order to make it more simple. So another example would be a to the power of 3 multiplied by a to the power of 2 is the same thing as a to the power of 3 plus 2, which is a to the power of 5. Okay? Now, when we're dividing, so let's think of b to the power of 2 divided by b to the power of 3. This is the same thing as b to the power of 2 minus 3, which is b to the power of minus 1. So the base numbers have to be the same. When we're multiplying base numbers, the powers can be added together. When we're dividing, then the powers can be taken away from each other. Okay? So let's quickly run through an example. Let's say we have a to the power of 5, b to the power of 2 multiplied by a to the power of 4 all over b. Now, there are two steps in this. We need to add the powers in the numerator, but then we also need to divide by the denominator to make everything a lot more simple. Now, when you just have a number, such as b, with no power, this is the same thing as having something to the power of 1. So let's start by simplifying the numerator. We are multiplying a to the power of 5 by a to the power of 4. So this is the same thing as a to the power of 5 plus 4. Now the b, there is nothing for us to multiply with. So we just leave the b as it is, okay? And this is all over b to the power of 1. Now, simplifying the numerator, we get a to the power of 5 plus 4, which is 9, b to the power of 2, all over b to the power of 1. Now we need to simplify this by simplifying the b's. Because we're dividing b to the power of 2 by b to the power of 1, we can take these powers away. So this is the same thing as writing a to the power of 9 multiplied by b to the power of 2 minus 1. And your final answer is a to the power of 9, b to the power of 1. Okay? So hopefully that made sense. Please make sure that you do write all of the rules down because they are important to remember and will really help you when we're working through the next few questions. Okay, so let's get started with the questions now. So question 3, just as a disclaimer, guys, you will notice that the question numbers are not consecutive and they do not start from 1. This is simply because the questions refer to the Cherry Hill specific material, but do not worry if you do not have access to this, as I will still cover the concepts in full. Okay, so let's get started. Question 3, we have y to the power of 3 divided by y to the power of minus 3. Okay, so when we're working through this, because we're dividing, so the first thing we need to check, are the base numbers the same? And they are. In this case, we have base letters. Now, because we're dividing two base letters, both with different powers, we can take these powers away. So we have y to the power of 3 minus 3, which is y to the power of, so 3 minus 3 turns into, so the double negative turns into a plus, which gives us y to the power of 6. Okay? And question 4, we have a to the power of 5 divided by a to the power of 9. So the base numbers are the same. So we can take the powers away. So a to the power of 5 minus 9, which is a to the power of minus 4. Okay, so it seems quite straightforward. Pause the video and try the questions on your own again and check if you get the same answer as me. Okay, let's move on. So question 9, we have y to the power of 3 divided by y to the power of minus 3 minus y to the power of minus 7 divided by y to the power of minus 3. Okay, so this one consists of a few more steps than the previous ones. Let's do this step by step. So let's simplify the first term first. So we have y to the power of 3 divided by y to the power of minus 3. Now, because we're dividing, we can take the powers away. So it turns into this. And then we have y to the power of minus 7 minus 3. Okay, so simplifying this, we get y to the power of, so 3 plus 3 is 6, minus y to the power of minus 7 plus 3, which is minus 4, and that's your answer. So we can't simplify this further because the powers are not the same. So we cannot take away two things that have different powers. For example, it's like taking away x cubed minus x squared. They are not like terms, so we cannot simplify this any further. In the same way, we cannot simplify y to the power of 6 minus y to the power of minus 4. Okay, question 12, we have b to the power of minus 2 divided by b multiplied by b squared. Okay, so again, a few more steps than the previous ones. Let's simplify the denominator first. So we've got b to the power of 1 multiplied by b to the power of 2. So we can just add the powers, giving us b to the power of 3. Now it's quite simple for us to solve. We are simply just dividing so we take the powers away. So we get b to the power of -2 minus 3. -2 minus 3 is -5, and that's your answer. Okay, so again, quite straightforward. I think once you practice it a little bit, you should be able to get the hang of it very quickly. Okay. Question 18, we have y to the power of 7 plus y to the power of 8 divided by y to the power of 9 minus y to the power of 4. So this question is a little bit different. We have 4 base numbers that are all the same, and we have 4 different powers. Now, we cannot simplify the numerator or the denominator because the numerator powers are different and the denominator, the powers are different. They are not like terms, so we cannot simplify this. One thing we can do is divide everything, numerators and the denominators, by y to the power of 4. Okay, this is because y to the power of 4 fits into every term. This leaves us with y to the power of 7 divided by y to the power of 4 plus y to the power of 8 divided by y to the power of 4. And this is all over y to the power of 9 divided by y to the power of 4 minus y to the power of 4 divided by y to the power of 4. Now, the numerator, the first term, we are taking the powers away because we are dividing, leaving us with y to the power of 7 minus 4 plus y to the power of 8 minus 4. Again, we are taking away, over y to the power of 9 minus 4 minus y to the power of 4 minus 4. This leaves us with, so the first term in our numerator, 7 minus 4 gives us 3, so we have y to the power of 3 plus y to the power of 8 minus 4, which is 4, over, now let's look at the denominator, we've got y to the power of 9 minus 4, which is 5 minus, so here we've got y to the power of 4 minus 4. Y to the power of 4 minus 4 gives us y to the power of 0. Now, anything to the power of 0, any number or any letter, always gives us 1. So 4 to the power of 0 is 1. X to the power of 0 is 1. 3 to the power of 0 is 1. So anything to the power of 0 is 1. So that's another important rule to remember. So we get 1 here, and that's your final answer. Okay? So pause this question and try it again on your own. And please make sure that you understand every concept and you do write the rule down as well. So y to the power of 0 is equal to 1. Okay? Thank you for tuning in. Remember, practice makes perfect. Never give up. I will see you in the next tutorial.